I just want to take a couple minutes here and discuss the notation and just sort of walk through where it comes from and how to use it and how not to use it. There are two different kinds of notation for the second derivative. First is we get by saying, hey, I'm going to take a function. I'm going to take a derivative of that. I take a derivative of that. So we're starting from the inside, we're working way out, and over time people just started dropping the parentheses. Now for what it's worth, we can also write the third derivative with three little things like that. We can write the fourth derivative with 4 hash marks like that, but it gets really, really long. So after a while, people decided they were going to write this. Now, if I put a little 2 up here, that's f squared, and so they don't do that. They put a little parentheses like this, and that means the second derivative. That means the third derivative, like this. And believe it or not, an awful lot of devices that we use take tens of thousands of derivatives, so it's good to have notation for taking derivatives. So that's actually just the first derivative. It's the hash marks and using them over and over. The second notation is much more powerful and a little bit harder to use. Remember, our derivative for the our notation for the derivative looks like dy dx, like that. Well, at some point, someone decided to start writing this as the derivative of y. And so this symbol right here became the derivative of. Don't ever write d dx equals. So this is expressly forbidden. It makes no sense whatsoever, and usually if you write it on a page, people will stop reading anything you write afterwards. That's very, very important. Now, the reason it's nice to have this notation is because I can now take the derivative of y. So here we go. I'm going to write down the derivative of, like that, the derivative of, like that, and then y. Now, if you leave off the parentheses and start writing stuff that isn't meaningful, you might write something like this. I see d dy. Now that's not d squared y, but that's what they started writing. And we're kind of stuck with it. For what it's worth, they use this notation much more in chemistry, biology, and not so much physics, but chemistry, biology, economics. It comes up a lot. Now on the bottom, it looks like dx times dx. And if they were honest about their abuse of notation, they would at least put parentheses in, but they don't. They write something like this, where we're supposed to remember that this dx came from dx and the top came from dd. But this is actually the more standard notation for the second derivative. And you can see that the third derivative would be very, very similar. Something like d squared y, dx cubed, etc. That's just the notation. There's two different kinds. We have the prime notation, where we have f prime, f double prime, etc. But even that has to be changed as we start taking tens of thousands of derivatives. Or we can use the, this is called the differential operator notation. This means take the derivative of operator. So let's take the derivative of y, and then we abuse the notation twice and we find ourselves writing d squared y over dx squared. But you shouldn't read this d squared y over dx squared. You should just read that, the second derivative.